Welcome to Maths for All. I'm Aisling Flynn. This is the line, and the line is part of coordinate geometry. So we'll begin talking about functions, which we've studied already. A function is a set of instructions to carry out on a set of numbers that you input. Complete the table below for the values of x from -2 to +2 for the function y equals 2x plus 1. Okay, so in previous lessons of functions we've used f of x equals. So for the line we use the variable y. So y refers to the outputs, what goes on the vertical axis. Okay, but otherwise it's the same as f of x. Okay, so the first one is done for us. For x is -2, my function is 2 times x, so multiply the x by 2, multiply the input by 2, and then add 1. So 2 times -2 plus 1 is -4 plus 1, which is -3. Okay, when the input is -1, what do we get? We get -2 plus 1, which is -1. When the input is 0, 2 zeros are 0, 0 plus 1 is 1. When the input is +1, we get 2 plus 1, which is 3. And when the input is 2, we get 4 plus 1, and the output is 5. Okay, and it says to look at the values of y above. So we're looking at this column here. Do they make a pattern? Now, yes, they do. Okay, so it jumps from -3 to -1, -1 up to +1, +1 to 3, and 3 to 5. Can you guess what comes next? Yeah, I think it will be 7. So, do they make a pattern? Yes. What type of pattern do they make? Well, we learned when we studied patterns that this is a linear, or if you like, arithmetic pattern. Okay, because they are rising by equal amounts each time. Each time we increase the input by 1, we are increasing the output by 2. So each time we're going up by +2. And what is the common difference of this pattern? Well, we've just said it, it's +2. Okay. So this is an empty graph, and it consists of a horizontal axis, which is the x-axis, and a vertical axis, which is the y-axis, and we call this the coordinate plane. We're going to use this as an empty map, and we're going to plot coordinates like you would on a map, north, south, east, west, but we use the x and the y-axis to place them. A couple is a set of coordinates describing a point, and it's written as x, y. Okay, so the couple gives us the coordinates or the position of the point on our coordinate plane, on our graph. Gives us a horizontal position and a vertical position. So use your table on the previous slide to write a set of couples for the function y equals 2x plus 1. So we did the calculations for that function on the previous slide, and if you recall, you can go back if you want, the first x value, or the first input, was -2, and the first output was -3. Okay, the second input was -1, and if you recall, our outputs were going up in 2s, so our output there, our y for this couple, is -1. The next one was 1, so that's our x with our y. The next output was 3, and the final output was 5. So each of those in brackets is a couple of coordinates which will allow us to plot a point on the graph. Okay, now we're asked to plot these points on the graph to the right. Okay, so there's the first one. So -2 is an x value, so you go left and right along the x-axis until you get to -2. There it is. And -3 is a y value, so you go up and down along the y-axis until you get to -3, and where those two coincide is where you get your first point. That's -2, -3. Okay, the next one is -1, -1. You can see that there, the second red dot. Then we have x value 0. Well, that will be in the middle, not left and not right. And it's not written in there. X value 0 is here. So it'll be right on that line and up 1. Okay. The next one is to the right 1 step and up 3. And the last one is to the right 2 steps and up 5. So there we have the 5 points of the function plotted, and you can definitely see a pattern or a shape. Join up your points. So in that case I take a ruler and I join them up, and what have we drawn? We have drawn a straight line. Okay, so and if you recall, we said that the outputs were given a linear pattern, and that's why it's called linear, because when you put it on a graph it looks like a straight line. Where does the line cross the y-axis? So my y-axis is the vertical one going up and down, and it crosses right here at y = 1. Okay. So let's recall for this function, y = 2x + 1. It has a common difference of +2, and there's a reason I'm writing these down, and it has a y-intercept, which we'll learn later has letter C, of +1. Okay, and that was the function. Okay, now we're given a different function, y = 3x + 2. Okay, in the domain from -3 to +3, so this is our start and our end, and we'll do it just as we did before. So you would complete a table like this, or indeed use the table function that on your calculator, which we saw when we did functions. Okay, so 3x + 2, we'll just do a few of these. So when the input, which is x, is -3, we get -9 + 2, which is -7. When the input is -2, we get -6 + 2, which is -4. When the input is -1, we get -3 + 2, which is -1. And you can see where this is going. When the input is 0, we get 0 + 2 is 2. 3 ones is 3 + 2 is 5. So you can continue, or better still, use your calculator to make the table, and we can see there's a definite pattern. We're going up in threes, so 5, 8 and 11 will be the last one. Okay, now what are the points coming out of this table? What are the couples? We'll have -3 was the input, the output was -7. When we had -2, the output was -4. -1, the output was -1. We have 0, 1, 2, 3 as our inputs, and we have 2, 5, 8 and 11 as our outputs. Okay, so we have 1, 2, 3, 4, 5, 6, 7 points for the graph. Okay, and here we are plotting them. Okay, that's the first one, -3, -7, so -7 wasn't included here, so you can extend it if you need to. Remember that the x value always comes first, and that's left or right, so we go back 3, down 7. Okay, the next one was back 2, down 4, back 1, down 1, in the middle, up 2, right 1, up 5, right 2, up 8, and we don't have that one actually. Right 2, up 8 would have been here, and right 3, up 11 would have been here. So, and then we could join them up as before. Okay, What is the common difference in the y values? Well, looking at our patterns, it was plus 3. Where does the line cut the y-axis? We can see quite clearly here it's 2. Okay, this was our function, so let me just write that down. The common difference was 3 and the y-intercept was plus 2. And just be making connections now in your head. Where do you see the common difference? Where do you see the y-intercept? Okay, so this time the function, they call it f of x this time, is 4x minus 2, and we're given our domain. So again, you can take your time going through the table, or you can use your calculators. So from minus 2 up to plus 3, our outputs will be, so 4 times minus 2, we get minus 8 minus 2 is minus 10. Input minus 1, minus 6, minus 2, and we'll just go to the next one, which will bring us into the positive numbers, is plus 2. The next one will be plus 6, and the next one will be plus 10. Okay, how did I know that? I'm seeing the pattern. It's increasing by 4 each time. Okay, and you can check that using your calculators. What points do we get for our graph? Well, our domain was the x values. Did I skip one there? Okay, so we only go as far as 3 in this case. And the outputs were minus 10, minus 6, minus 2, plus 2, plus 6, and plus 10. And then we put those on a graph. What do we get? That's my back 2 down 10. Back 1 down 6. In the middle down 2. Right 1 up 2. Right 2 up 6. And right 3 up 10. Okay, we didn't have the 310 one there. We can add it afterwards. It's up there. Okay, and joining up, you can see that it is linear. What's the common difference? We mentioned already, it's plus 4. Where does it cut the y-axis? You can see here it's minus 2. This was our function, so make some connections there again. The common difference was 4, and the y-axis was minus 2. So you can see them in the function. So this table is to draw all of that together. So the very first function we looked at was y equals 2x plus 1. What shape was it? We discovered that it made a straight line when we drew it. The common difference was plus 2, and it cut the y-axis at plus 1. Okay, the second function we looked at was 3x plus 2. It was also a line. We saw that the common difference was plus 3, and that it cut the y-axis at plus 2. The third one we looked at, it was called f of x, or we see that we can use y, is equal to 4x minus 2. It was also a straight line. The common difference between the outputs was 4, but it cut the y-axis at minus 2. Okay, so now, can you see some patterns there? Can you see where those numbers occur in the function? And can we, without drawing, look at function d? Y equals 6x plus 3. Can you tell me what shape it's going to be? Well, it will be a straight line. Okay, it takes the same form as the previous ones. Can you tell me what's the common difference? Well, we can. So when we had common difference 2, we have 2 beside the x. 3 had 3 beside the x. 4 had 4 beside the x. So what's beside the x here? 6. The common difference is going to be 6. Okay, and let's look at where it cuts the y-axis, which is called the Y-intercept. The word intercept means to cross over or interrupt. Okay, so plus 1 happens here at the end of the function, plus 2, minus 2, minus 2, and so for this one we can see that the intercept will be at plus 3. Okay, following the format. And we're getting that from what's called the equation of the line. the equation of the line. We can take that information straight away. Okay, so this is what they look like. Y equals mx plus c. And the equation of a line comes in the form y equals mx plus c. The number m beside the x describes how quickly the line is rising or falling. So we refer to that as the common difference. So each time you increase the input, what is the output increasing by? So we had in the previous examples 2 and 3 and 4 and finally 6. So on the graph, however, this is called the slope. Okay, and slope describes how quickly a line rises. So is it gradually? Is it very quickly? Is it super quickly? Okay, and bigger number beside the x means a bigger slope. And the number c at the end of the equation tells where the line cuts the y-axis, and this is called the Y-intercept. Now it's your turn to try some work based on that with your quiz and written exercise.